Okay, you're given this function f of t, 3 over t squared, and you're asked to calculate the derivative of that function using the definition of derivative as opposed to any derivative rules. So f prime of t, the derivative definition of derivative is the limit as h approaches 0 of f of t plus h. That's what this first term is right here. Minus f of t, that's what this term is here, over h. Okay, now if you tried direct substitution right now, you would get 0 minus 0 over 0. So the key is to change the way this expression looks so that we can cancel out this h in the denominator. And if you treat this as a complex fraction, little fractions within the big fraction, you can simplify that complex fraction by multiplying numerator and denominator of the big fraction by the LCD of all these little denominators, which is t squared times t plus h, the quantity squared. So that's what's happened right here. We've multiplied top and bottom of the big fraction by the LCD of all the little denominators. And when we do that, taking this expression right here times the first term, the t plus 2, the quantity squareds cancel out, and we get 3 times the factors that remain, which is this 3t squared right here. And when we take this expression times the second term in the numerator, the t squareds cancel out, and we get minus 3 times t plus h, the quantity squared. And in the denominator, we'll just get h times that LCD. Now, if we simplify the numerator, we'll square t plus h, squaring a binomial. If we square that binomial, we get t squared plus 2th plus h squared. And then if you could just picture distributing the minus 3 times each of those terms, this is what you get. The 3t squareds combine to 0. There's an h factor in each term that remains in the numerator. If you factor that out, here's the terms that remain in the numerator, minus 16 minus 3h. The whole key is that we got these h's to cancel out. Now when you try direct substitution for h equals 0, we don't get 0 over 0. We get, well, this term becomes 0 as h gets close to 0. So we get a minus 6t in the numerator. This factor in the denominator becomes t squared. So we get t squared times t squared is t to the 4th. Finally, one factor of t cancels out. There's the derivative of the original function. Okay, and that derivative, one of the things that it represents is the slopes of tangent lines to the graph of that function. You'll be seeing that later. There you go. Hope that helped. If you have any questions, post a comment.